Let us talk about this problem. We are given an array. Our task is to find out if there is a sub-array with zero sum or not. Let's first quickly define what do we mean by sub-array. Sub-arrays of 10, 20, 30 are 10, 10, 20 and so on. These are all sub-arrays. Please note that sub-array means contiguous elements. For example, 10, 30 is not a sub-array because 20 is missing, right? We can't skip some elements. We need to pick contiguous elements only. So now we understand sub-array. Let's take a look at these examples. In this example, we have array 1, 4, 13, minus 3, minus 10, 5. And if you take a closer look at this, there is a sub-array with zero sum. That's why our output is yes. Now let's see this example. Here we have a sub-array with some zero, so our output is again yes. Now if you see this example, there is no sub-array with zero sum, right? This sub-array sum is minus 1, then this sub-array sum is 2, right? So there is no sub-array with zero sum. In this example, we have a sub-array with zero sum single element. Now please pause this video and try to write down a function that takes an array as input and this function returns true if there is a sub-array with zero sum, otherwise returns false. Let us first talk about a naive solution to solve the problem. The idea is simple. We consider every element as beginning element and find sum of all sub-arrays beginning with it. And if we find any sub-array with sum 0, we immediately return true. So we begin with I equal to 0, we consider it as a first element of the sub-array and we consider all sub-arrays beginning with it. So what all sub-arrays we will have beginning with 0? We will have this element itself, then we have 2 elements, then we will have 3 elements, then we will have 4 elements. Now when we move to next iteration I equal to 1, we will have 1 element, 2 element, 3 elements, right? So for I equal to 0, we are going to consider the ending point as j equal to 0 first. We compute the current sum as 4, then we consider the ending point as j equal to 1. We update the current sum as 1, then we consider ending point as 2, then we consider ending point at 3. At none of these points, we find sum 0, right? So current sum never becomes 0, we never enter inside this if condition for I equal to 0. Now we begin our next iteration of outer loop. We begin with I equal to 1 and we consider j as 1, which means ending point as j itself. We find the current sum as minus 3. Then we consider the ending point as this. We find the current sum as minus 1. Then we consider ending point as this and we find the current sum as 0. So this is the point where we enter into this if condition, right? We have this equal to 0. So we enter inside this if condition and we return true at this point, right? And we stop our execution. Now if there is no sub-array with zero sum, then what will happen? You will traverse through all the sub-arrays, you will never inside this if condition, you will come out and return false. The time complexity of the solution is clearly big O of n square. See, it may take big O of n time or constant time also. If first element itself is 0, then it will take constant time, right? But in the worst case, when there is no sub-array with zero sum, it is going to take n square time, because in this case you will consider every sub-array, right? And there are theta n square sub-arrays, right? You will consider every sub-array and you will find sum of every sub-array and then you will decide, okay, there is no sub-array with zero sum. So cases when you come here and return false at the end, they are definitely n square time complexity cases. Now please pause this video and think of a solution that works in big O of n or linear time. The idea of efficient solution is to use prefix sum and hashing both techniques. Let's see how do these techniques work together. Let's say we have this array from a0 to an minus 1, right? And let's say the sum of this subarray is 0, ai to aj. Now we want to figure out somehow efficiently that there is a subarray whose sum is 0. So the trick is this: you traverse the array from left to right, you keep computing the prefix sum. And if this subarray has sum 0, then prefix sum from a0 to ai minus 1 should be same as from a0 to aj. Right, this prefix sum should be equal to prefix sum 2 if this subarray has sum 0, right? If that is the case, then these two prefix sums must be same. Why? Because see, this sum is 0 and you are adding 0 to the sum, right? So you will get the same sum. That's why if there is a subarray from ai to aj 0, then prefix sum from a0 to ai minus 1 should be equal to prefix sum from a0 to aj. That's the idea we are using. Now, how do we check if prefix sum is repeating? How do we check that this prefix sum appeared here, now it is appearing again? For that purpose, we use hashing, right? Hashing serves the purpose. what you do is you keep traversing the array from left to right. You keep computing the prefix sum. You keep putting the prefix sum into a hash table, right? And when you find a prefix sum which is already there in the hash table, you return true. That's the simple idea. Let's understand this with this array example. Let's say we have this array 3, -3, 4, -3, -1, 1. We initialize the prefix sum as 0. We initialize our hash table as 0. Hash table is empty. Now we traverse this array, right? And in one traversal, we are able to find if there is a subarray with sum 0 or not. So what are we doing? We are computing prefix sum 1 by 1 -3. Then we are putting into the hash table. Then we are computing the prefix sum -3 plus 4, which is 1. So 1 is not present in the hash table, so we are putting it. Then next prefix sum -2, right? Some of these 3 elements. So it's not there, we are putting it. Then next prefix sum. Next prefix sum turns out to be -3. It's already there in the hash table. So we figure out, okay, we have a subarray with sum 0. And you can notice that this prefix sum is already repeating. It's already there because this subarray has sum 0, right? This is the point, the ending point of the subarray, where we figure out there is a subarray with sum 0. So now you have enough idea. Please pause this video and try to write down the complete function that takes an array and returns true if there is a prefix sum, otherwise false. Here is implementation of the idea. This side we have C++ implementation and here we have Java implementation. So what are we doing in these implementations? We are first creating a hash set in Java or an unordered set in C++. Then we initialize our prefix sum as 0. Then we run a loop through all the elements. For every element ARRI, we add it to the prefix sum. And then we check if this prefix sum is already present in our hash set or not, or unordered set or not. This is how we check in C++. And if it is present, we return true. Now here is something new, something interesting. Why are we checking for this condition explicitly? If pre-sum is 0, then return true. See, this is to handle the cases like this. If you have an array like this, -3, 2, 1, then what will happen here is, you will have subarray as sum 0, right? You have this subarray, the whole array as 0. In fact, even if you have one more element after it, 4, then this subarray is 0 sum. But if I remove this condition, then the solution would not handle this because there exists a prefix with sum 0. So no prefix sum repeats because the whole prefix itself has sum 0, right? That's why we have this condition to handle these cases when you have a prefix with 0 sum. So if the prefix sum itself becomes 0, then we return true. And after checking for these two conditions, right, if any of these two conditions are satisfied, then we immediately return true. And if these two conditions are not satisfied and we have checked for them, then we add prefix sum to our hash table so that when we do the next iterations, we can check if it is already seen or not, right? That's the simple idea. We are simply creating a hash set or a hash unordered set. Then we are computing the prefix sum 1 by 1. We are checking if the prefix sum is already present in the hash table, then we return true. And if the prefix sum becomes 0, then also we return true. Otherwise, we simply add the prefix sum to the hash table for upcoming iterations. Now let's talk about time complexity of the solution. See, this solution clearly requires big O of n time. For every array item, we are doing these operations and all these are constant operations. This is in C++ and this is in Java, they both are constant operations. See, this is checking whether an item is present in the hash table or not, which is a constant operation. Now, these are constant condition checks. Adding an item to a hash table is also considered constant operation. So, overall time complexity of the solution is big O of n. Please note that I've used big O notation because we may break before checking all the elements itself. Say, first element is 0 itself, right? So, n is an upper bound.